So let's look at this example here. Endothermic changes. When it's a physical change, write this down. They absorb energy into the molecules. Which of the following there is going to be endothermic? Think about it. Liquid, water becoming ice. In order for liquid water to become ice, okay, does energy have to go into the water to melt it to turn it into ice, or does energy have to be taken out of the water to make it form ice? It has to be taken out of it. So it is giving off, all right? That is going to be exothermic. Gas turning into liquid water. Again, you have gas that is condensing. That's condensation. Condensation does not mean that it is absorbing energy. As you absorb energy, it changes state. It would go to the higher state. So it would go from a liquid to a gas if it was absorbing energy. And that's where this one comes into play. This is a physical endothermic change. Liquid water, you add energy to it. So liquid water plus energy is going to turn into a gas. You boil water, it turns into a gas. It is absorbing, the water is absorbing energy. That's endothermic, absorbing. Ice, melting into a liquid. Again, ice, you add energy into it as well. Plus energy, it's going to turn into liquid water, all right? So think about this as well. When you're given a question like this on the test, ask yourself, if I add energy to liquid water, does it become ice? No, I have to take energy away. So if I add energy to liquid water, it becomes gas. Ask yourself that question, do I add energy to it? Yes, then I know there that it is endothermic. Mathematical example here. Delta H plus here, or minus, well, is it going to be delta H plus or delta H minus? Endothermic, exothermic. If we subtract here water and ice and we get a plus 333, right? Delta H is positive. We know if delta H is positive, then it is a endothermic change. Remember, delta H positive is endothermic. So I should just give you this. I could say delta H plus 333 joules. Endothermic or exothermic? And you write in the answer. You should be able to say, yeah, it's endothermic. I know it's endothermic, all right? What about a chemical one? A chemical example of an endothermic change here. Well, chemical involves breaking and forming of bonds. And when we break and form bonds, there are two different things that we have to look at. And breaking bonds here for energy, we know that there is not going to be any extra energy given off. There isn't. No extra energy being given off. So our example that we can talk about is photosynthesis here. So we have 6 CO2, carbon dioxide, plus 6 water molecules, yields C6H12O6, which is glucose plus oxygen. When trees photosynthesize, they give us air, which is good. We like to breathe, right? Again, delta H is positive. Delta H being positive means that it's endothermic. That's all I have to give you. And what you need to know is that it's endothermic, all right? So make sure that you know that. Sorry for that little interruption there. The webcam kind of froze. But I was talking about endothermic being positive, delta H positive, the change in energy, the change in heat is positive, and that means it's endothermic. It is going to be absorbing energy. So the most important thing here to take from this is my delta H positive or negative? If it's positive, it's endothermic. Make sure you know that. Let's go ahead and move on to some exothermic changes. Exothermic changes, now exothermic changes, again you should be thinking exo is giving off energy. Any type of physical change that occurs here, we are releasing, giving off energy to decrease the energy of the molecules. So ask yourself those same questions. Which one of these is exothermic? Well, it's very, very easy to determine which one is going to be exothermic. Ask yourself, in order to form ice, does the liquid water have to absorb energy or lose energy to become ice? Well, in order to lose ice, I need the water to lose energy, so it becomes the molecules that are moving in a water. Remember, they're kind of moving like this. If they lose energy, they start to slow down and become more of a solid, and now they're just vibrating, right? Just vibrating. They've lost energy, they've slowed down, and that is what an exothermic change is there. So A here is an exothermic change. B, liquid water turning into a gas like we saw above in the previous example is endothermic, because if I add energy to gas, it changes phase. If I add energy in the water, it changes phase into a gas. C, to take a gas from a gas to a liquid. Again, it's exothermic. I am releasing energy. Ask yourself that question. If I add energy, does it become liquid? No. I have to take away energy from a gas to turn into a liquid. Again, with the particles. As a gas, they are bouncing everywhere, all over the room. And as I slow down, as it gets colder and colder outside, right? They start slowing down. The gas particles become closer, 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 and then they bond together like this, and then it's more of a liquid. So that is the process there. Think about that in your head about, do I add energy or do I have to lose energy? So those would be physical type of changes, changes of state, either being endothermic or exothermic. Also, delta H. Remember, delta H negative means exothermic. And we said it before. I've said it maybe 4 or 5 times in this video. I think it's important. Delta H is negative. It is exothermic. Make sure you know that. All right. And here's a good point to make here. This is just something good, good information. If 1 gram of water, it has to lose that much heat in order to become ice. That's a lot of energy to become ice. That's why water has a high specific heat. Now looking at some chemical exothermic changes. Chemically, breaking and forming of bonds, when bond breaking energy, we know that energy is going to be released to form bonds. So make sure you write that in there. It is being released to form bonds. So now respiration, breathing here. Basically, we end up with a negative value, and delta H negative means exothermic, means it's giving off energy to the system. So the reaction here, we have reactants and products. When the products form, they give off energy. They give off energy. And that's very, very important to know that and be able to identify those. Real quick, we're going to finish here with a few examples on your own. See if you can answer these questions. Trying to answer these questions. Some common reactions that you might see. These are great examples, possible test questions. Do you predict them to be exothermic or endothermic? And a chemical or physical, and why? Write out the reaction and then support your answer. What kind of H value do you think each will have? Have these answered, bring them into class for me to check to make sure that you have watched the video and identified each one of these and get the answers from me, because I'm going to ask you these questions on the test. You need to know, what is each one of these? Is it endo or exothermic? Think about it. Burning of methane. Methane's a gas. Is it going to absorb energy or release energy if I burn something here? Okay? Dissolution of ammonium nitrate in medical kit packs. Again, I'm taking ammonium nitrate here, and that is, think of it as one of those ice bags that you take and you break it, and you put it on if you're spraying an ankle or something. Is that getting colder or hotter? And if so, if it's getting colder, is it giving off energy or is it taking in energy? Think about that. Allowing dry ice to sublime. Sublime is, remember, turning here from a solid directly to a gas. So I'm going from a solid to a gas. Look at our previous examples. Was that giving off energy or taking in energy to change from a solid to a gas? Fireworks, an explosion. Is that giving off energy or taking in energy? And then taking water vapor when it cools down at night to become dew. Again, I have gas molecules or water molecules that are bouncing around, and then they have to slow down and cool off, and they kind of become water. Is that endothermic or exothermic? Think about that, and then also try to identify chemical or physical changes. If you have questions, see me in class, please. These are very, very important to know. Make sure you check them with me.